Hey everyone, in this video we're going to go over Octane materials. We're going to start with just a general intro on how to set things up. Then I'm going to go through some of the different node types that you should be aware of, mention a few special cases, and kind of a few of the most common things you might need to know about. However, then I will do another series of smaller, shorter videos that go over specific special setups. I thought about including them in this video, but I thought for one, this list might be growing over time, but also might be easier for people to find if they're like individual videos that will be released after this one. So yeah, let's get started. All right, so when you first create an object that doesn't have a material applied to it, at least in the current build of Octane, you will see this kind of magenta material, and this generally will tell you that this object does not have a material applied to it. So first we have to create a material to apply. And so we're gonna go into the material context here, and we're just going to drop down an Octane material builder. And this Octane material builder is going to be the main place you build materials inside of. You could, in theory, build Octane materials just kind of in the general material context. However, you would see all other nodes of different render engines in here. However, once we hop into the Octane VOPNet, we can see this is only limited to Octane nodes. A few other ones that is more of like a bug on the side effects side, but like 98% of these nodes are all Octane nodes. And so to apply this material, for one, you can just take this material and drag it onto the object, and that's like one easy way to apply it. When you do that, under the object, under the render tab, it will be applied here in the material parameter. However, oftentimes you might not want to apply material to the whole object, but to specific faces or sections of an object. And so you can also do that inside of SOPs using the material node, and then just pick the material in here. So for example, in this case, if we want to apply this concrete material that we were using before, you could do that. And you can even just apply that to part of your object. And then anything that doesn't have a material applied to it will default back to kind of this material parameter if it's set. Quick note here, we do have kind of a handy Octane quick material, which is basically like this kind of Uber material that you can apply directly in SOPs. That is really great to kind of just quickly throw something together. And this also exists in the material context. So also in here, I can drop down an Octane quick material and apply that. And it's basically the same thing. One thing to note though is that in most cases, if you change any parameters here, it will kind of like trigger a reload of the whole object. And so if you have a heavy object, this tends to be not like the most kind of efficient way of working. There are a few different node types in Octane that all kind of serve a different purpose, and it'd be kind of good to understand the difference between them, and also note that they're not interchangeable. And really, based on like the input pins that you come across different materials, they require a certain type of node to be plugged in. You can't just like plug a projection node into a color pin, for example. And I'll go over that in a little bit more detail in a second, but just be aware that there's like these different type of nodes, and you kind of have to use them appropriately. For one, we have our material nodes, and the one that you'll probably be using the most, and that's also what you're going to find in the Octane material builder by default, is this material standard surface node. And this is kind of like a Uber shader that includes almost everything you need. So you have like your your normal base color, you can add metalness to your material, you can turn it into like a glass, there's subsurface built in here, there's coatings, sheen, emission, and a bunch of other stuff. So this is your multi-purpose everyday type material, and it's built to the Arnold standard surface standard. So you're going to find a very similar material like this in most render engines. Then there's the Octane universal material, which is kind of like Octane's native Uber shader that existed for a long time. And really, most of the time, I just use the standard surface because I feel like it covers my needs in pretty much most or if not all situations. But then you also have more low-level materials that are specific to different properties. So you have like, for example, a metallic material that just does metallic stuff, and you kind of have a bunch of metallic specific settings here that kind of go a little bit more to depth, where you can get like different metallic reflection modes. You have your glossy material, and there's also diffuse material. You have like a specular material, which is like a glass or water shader or whatever. But then you also have utility materials like this material mixer, where you can mix between different materials. You have like a normal material that is basically just an invisible material, which by itself doesn't really do much, but you can, for example, mix it with another material to achieve different things. One other thing that I should probably mention with materials is that there's also a material layering system that you can actually use to layer like different material layers basically on top of each other. And there's a bunch of other kind of like materials you can play with and check out, that some of which we will also go over in other videos. One other thing to note is you have this material pin here that is specifically for surface objects. On the other side, if you're doing like a pyrosim or a cloud or something, then you actually want to use some of these medium nodes, and those actually are plugged into the medium pin. But we're going to go over volumes in a different video in more detail. All right, and then the next kind of category that you're going to encounter is these color/texture nodes, what I would call them. And if we plug these in, you can see there's use a bunch of pins that expect a color input. These can include all kinds of things. So in this case, we just have a basic color here. It can include an image texture, which we're using the texture image RGB, in this case loading a wood texture from Grayscale Gorilla. But we also have more procedural textures like noise, which you will use in all kinds of situations. You have a dirt shader, which basically is kind of like an ambient occlusion shader that adds dirt into kind of like crevices and stuff. You have procedural type textures, for example, flakes, which is helpful for doing like car paint or like glittery surfaces like sand. But you also have some more like utility type texture color nodes. For example, this Z-depth tool. So if I move my camera around and zoom in and out, you can see that this kind of like changes the color of the object based on the distance to the camera. Or this tool position node, which basically just like samples the world space position and puts it into your RGB channels, which can also be used for different special kind of shaders or whatever. And then we also have some nodes that don't necessarily create texture or color input, but that modify it. So in this case, we are using like the tool image adjustment. And if I plug this wood texture in here and wire that through this image adjustment, here I can like, for example, change the contrast or the gamma. I can tint and do some like color correction to the image or like shift the hue. And there's a bunch of other ones like that. There's also one that you will use pretty often probably is the tool multiply textures. So if you're wanting to combine a color and an image by multiplying the two values, you can do that. And there's also a mix and add version of this. But yeah, there's kind of like a variety of tools like that. And these can be found under textures. You'll find more like the, your colors, different types of colors or image texture type stuff. And then under procedurals, you'll find more of like procedural textures like noise, checkers, curvature, and dirt or fall off, which is kind of like a Fresnel effect. But then under tools, you have a combination of modifying nodes like the image adjust node that we just played with, or like color correct node, but also some nodes actually create like a texture from scratch, like the Z-depth or the tool field ones can also be helpful if you want to make a spherical gradient. You can use those as well. But I would say that the tools are a little bit more utilitarian, while the procedural ones usually kind of are more on like the creative generating an effect type side. And kind of like with materials, with textures, we also have the texture layer system, and there's a bunch of texture layer nodes that you can use here that all plug into the composite texture node. And this allows you to build like really complex textures if you wanted to by combining different things, almost like in a Photoshop style layer system. And I'll probably make a dedicated video on that as well. And then we have our projections, and these projection nodes basically determine how a texture or procedural texture is applied to an object. So in this case, if we have an image texture applied, usually by default this will use a mesh UV. So if I plug a mesh UV here into this projection pin, which is the only pin that it will go into, we can see that nothing really changes. Now we could change this to like a different UV set. If there was like a UV2, UV3 set, we could switch those. But then we can also do something like plugging in a box projection, which just applies the textures basically straight onward. And you don't need UVs for that to work. You can do sample position, actually use samples like just the UV space of the camera. So in this case, move the camera on, you can see this image kind of like just sticks to the surface. So this is kind of helpful if you have like a back plate, for example, that you always just want to be projected from the camera. And there's a bunch of more utility projections like that. We have XYZ to UVV, which basically takes your XYZ position and uses that to project. Now, if we use that for an image texture, we'll just project it from one angle because the image is only like a two-dimensional image. However, if we use it with noise, this is actually the default projection style for noise. So if you can see, if I remove this, nothing really changes because by default noise actually uses kind of like your world space input. However, I could plug in a mesh UV node and now the noise would actually be like based on your UV space. And something to note when you're using, for example, a box projection, if this is set to object space, if I go here into my object and I transform my object, like the texture sticks because it reads the world space of my object. However, if I transform the object within SOPs, you will see that these textures kind of like slide around. And that's one thing that was added recently is if you go under Octane object properties, under attributes, enable rest position, and you have to make sure you have a rest node here that creates a rest position. If you do this before and then in the material under the projection, if you enable use rest attributes, now it actually uses this rest position instead of your actual position of the mesh. And so you can do things like rotate a mesh or even distort a mesh, and kind of like the textures, even though our normals are getting messed up here. It's not a normal node. Obviously this is pretty awful, but as you can see, the textures do stick. That is something that they recently added, which allows you to have mesh deformations and the textures not slide around. Just do note that when it comes to projections, there are some limitations, and that is for one, this rest attribute does not support bump maps, and hopefully that's something that will be changed in the near future. We're still in the alpha for Octane 26, just something to note. Also, if you're using displacement, really the only projection type that is supported by Octane's texture displacement is UV, and the distorted mesh UV also seems to work. And we're going to talk about displacement here in a moment a little bit more. One quick quick note while we're talking about projections, there's kind of a special case, and that is the triplanar projection. Usually all you have to do is plug in a projection on one side and then you're good to go. However, with a triplanar projection, we need this kind of like triplanar node on the other side. So let me just load a different object here that has like some rounded edges. Quick thing here, you can see that we're getting these kind of ugly shading errors, and there's a little button here you can click Smooth Shadow Terminator that helps kind of like when your mesh isn't super subdivided to kind of like smooth out some of these kind of shadow errors with low poly meshes. So the triplanar projection is really quite similar to the box projection with one key difference. If we have our box projection plugged in here, we can see that these edges are sharp. And so, for example, if I plug in a transform 3D and I like rotate it, you can see that these sharp edges kind of move along with the projection. So it's not like a geometry thing, this is a projection thing, just because it's based on the angle of the surface, it'll use a different direction to project to. Triplanar, on the other hand, what this does is it blends this. So it also kind of does the same thing, but we have a blend angle, and so we can decide like how much to blend these surfaces together. Depending on the material you're using, this can sometimes result in like a completely seamless transition. In this case, we have wood grains that kind of run into different directions, so that might not be as pleasing. Maybe if we blend this enough, it can definitely work better, especially here on this side where the grain runs in the right direction with no blend angle, which is what the box projection would do. You have a really sharp transition here, but if you blend this, it can almost become invisible. Then again, you can use rest attributes here, which is great if you have deforming meshes. Yeah, this is kind of like the only one that has like the special setup, and it's a little bit annoying to set up manually because you have to like plug in, you know, the texture into all of these different inputs. However, we did add a little script that makes this much easier by right-clicking here, Octane Triplanar Setup, and it just kind of like does all that for you. And then kind of alongside with our projections, we have transforms. And these transforms, like a transform 3D, can be plugged into, like, for example, a box projection, and we can use this to actually rotate and move the projection kind of like in 3D space. Or we can use transform 2D to actually just modify the texture. So instead of moving, like in this case, this projection around in 3D space, we're just moving the texture around in 2D space. If I do a rotation here, we can see it doesn't rotate like the 3D projection, it just rotates the texture around itself in UV space. One thing that trips people up on the regular is, let's say you have a 2D transform and you might want to like do some kind of distortion effect to this 2D transform, and maybe you think, you know, I'm going to create a noise texture and plug this into like the translation. This does not work, because if you check the pin here, it says translation one's a float, or there's some other ones that are one integer, and these actually can only accept like a single value. So you can use these like float or integer nodes if you wanted to use a node, but usually these correlate to the parameters in here, and really for those you can't use any kind of like texture or color based input. They have to just be single values. So if you wanted to do something like this where you plug in like a noise into the translation, there are some specific nodes that can do that. So for example, the distorted mesh UV, if I plug this in here, and by default it's the same result as a UV node. However, I can actually plug in a texture, and now we zoom in here and I like change the power, you can see that it like distorts our image by kind of like moving the UVs around using a noise. And there's another one like this called distorted UVV, which is kind of like the same thing. So if you're using like a noise, in this case, we plug this in, we can actually plug in like this into the translation, and we can kind of distort a mesh, but using 3D space. So there are ways to do this, but just note that you can't just plug something like that into like these integer or float pins. And then finally, we have like some of these other kind of like special type pin node types that are one-off. So for example, our emission texture, there is another emission blackbody node, and so these specifically go into emission pins, or our rounded edges node that specifically goes into the rounded edges pin. So like this one, for example, you can use to add like little edge highlights. So more like by default, there's like a sharp edge there. We can kind of like round it off without having to add extra geometry. And then we have a displacement. That's also like a special node that kind of has one specific pin. And that's one example where you might want to just plug in a texture directly into the displacement input, but actually is not how it works. You have to run it through a displacement node where you actually set some of like these overarching displacement settings. Let's dive into displacement a little bit more, because displacement is one of those features that Octane does incredibly well. However, you have to just be aware of its limitations. So first of all, in Octane, there are kind of two different types of displacement. If we type in here displacement in our tab menu, we can see there is a displacement and then there's a vertex displacement. Now, vertex displacement is kind of your traditional displacement that just basically pushes your geometry around. So decent enough geometry, or you have to add subdivision to have enough basically resolution there to get the detail that you want. The normal displacement, on the other hand, that's like not the vertex displacement is like a texture displacement. So the detail you get is based on the resolution that you choose. So let's plug in this displacement here. And then here we actually have a grid that doesn't have any subdivisions. So you can see there's no lines, even though we have the smooth wire shaded mode enabled. So there's absolutely no detail on this geometry. But if we plug in a texture here and we up this displacement height, we can see that we actually get a fair bit of detail. And currently we have this set to 1024 by 1024. We can up this even more by like increasing it, for example, to 4K by 4K. And so we just see that there's like a crazy amount of detail going on. And this is like a marble type texture that I'm using here. Now, one thing to note with this texture displacement that it is limited to work within UV space. You have to have your model UV unwrapped, and you can't really use any kind of like other projection types, for example, box projection or triplanar projection. Those are not available for this texture displacement. One other thing to note is that before Octane 2026, if we change this compatibility mode back to 2025, with normal image textures, things would work as expected. But if you were to use a noise, for example, you wouldn't get anything. And so let's add our UV projection. And so to use procedural texture setups, you would have to use a tool-baked image node. And what this tool-baked image node does, you can think of it as like if you're creating a texture in Substance Designer, this basically converts kind of like your texture setup into like one baked image that then is used to displace. And we can set a resolution here. So for example, 2048 by 2048. And then this can be used to do displacement. But since Octane 2026, and currently we're still in alpha, so there are still some issues with it, but we can actually use noise and other procedural elements directly now, however, only in UV space. Now, the only other projection that seemed to work for me using this tool baked image, even Octane 2026, is the distorted mesh UV projection. And I assume this one works because it still works in UV space. So again, it's not really using like the UVs of the mesh. It just bakes it down basically to an image, regardless of like what mesh is actually being used. So in this case, I could use again a noise and plug this into translation, and maybe let's turn down displacement. And so we can see that we get some kind of like a distortion here. And then a few other notes here in the displacement. You can use placement direction. With a grid, this matters less, but let's switch to a box here for a second. And if you set this to follow smooth normal, you can kind of get like a better cohesion along the edges, which is, you know, still not great because the textures don't line up, but that is one thing. And then filter type here, you can basically use to kind of like blur the displacement. Now, if you don't want to deal with these issues, or you want to, you know, be able to just do your texturing directly in Octane procedurally using noises and triplanar displacement, that kind of stuff, you can use good old vertex displacement. The downside with vertex displacement is that you need the resolution. So let's drop a noise in here and let's plug that in. And we're already seeing something here, but we don't have the resolution for it. So let's really bump up the subdivision level to something high, maybe like 7. Immediately we can see that we get displacement, and we are using noise right now, so everything's kind of like being displaced as you would expect. We can really play with this without any limitation. You can also use an image. Let's add the triplanar setup to it and plug that in here, and that also works as you would expect. And the nice thing is, at least, that you can add subdivision in here. Another option is, let's go into our box, let's remove the bevel, and let's say you want to subdivide it but you don't actually want it to smooth out. What we could do is here under the Octane object properties, under the geometry settings, we could add subdivision here, and by default it will do kind of the same thing where it smooths it because it's using the Catmull-Clark subdivision scheme, but we can actually change this to bilinear. And now if we crank this subdivision, we can see that we actually are not getting any kind of like smoothing of the corners. So it's just subdividing basically the geometry without changing its positions. Now currently we have this issue where we're getting these stretched corners. I think we can mitigate this by in the vertex displacement setting the mid level all the way to 1, and that way any of the offsetting happens inwardly. We can see that we're keeping these sharp edges. That's kind of, I guess, one way to do it. You know, that still gives you more flexibility. The downside is that, again, it is based on geometry, and depending on what your geometry looks like, subdividing it could cause other problems. The one other thing to note too is that you cannot blend two texture displacement nodes in any way whatsoever. Basically, you just can have one texture. On the vertex displacement side, though, and there is a vertex displacement mixer where you could combine like different displacements. Let's go through a few little material example setups. So if this is like your first time building materials, you'll get an idea of maybe where to start and maybe an idea of how to approach this. So the first one is going to be kind of like an abstract, fully procedural type material. So we're going to start with a noise, and I think I'm going to use the FBM flow noise. And this is an interesting noise to me because I don't fully understand how it works, but just fiddling with it, I find that I've gotten some like cool results. And the biggest thing that I really like about this, so let me just play around with it. I'm going to take out all the color, because I don't really care about the color. And then let's see, let's get some like interesting noise here. And then if we move this look, you can see that things like start warping. And if you really push this, you feel like you can get some pretty cool kind of like warpy, I don't know, I really like this look. Playing with these different settings, you can get some pretty cool stuff. I think the one thing I don't really understand is how these colors work. And I guess it's kind of like multiple noises or something like that, like layered on top of each other. But yeah, what I do know is that I really like the results you can get with this. I guess the octaves, we can make it like simple, or we can really get some more like detail in there. Let's use that same texture and actually plug this into our bump map to kind of give this some depth. So if I zoom in here and under the geometry properties, I can turn up the bump map and we can see that we can like get some depth. And obviously if we really overdo this, that doesn't look very good. But if we just give it like a little bit of subtleness, it kind of already feels like it's like actual like layers of paint or something on here. And then I want to make some of this section emissive. So let's drop down another noise, and we're going to use this to control which parts of the object are like going to be glowing. And so we'll plug this here into our emission weight. And let's really up the contrast. The contrast, just gives contrast to the whole thing. And then gamma, you can kind of offset like which sections are like, kind of the balance of it all. And then let's drop down and transform here to kind of make this noise a lot bigger. Yeah, it's looking pretty good. And then let's bring some more detail in. So using octaves, you make this like really simple. It has like very little detail. And then the more octaves we add, the more like finer detail we get. And then omega, we can kind of change like how much this like roughens up the edges of the noise basically. So those parts are now emissive. And let's give some color back, or like some more detail back to the emission again. And we're going to go back to our flow noise, but we're going to remap this noise using a tool gradient node. And this basically is like a gradient ramp. So like you can use this to change the coloring of the input, and you can kind of like, do some pretty cool stuff with it. But I actually really enjoy these presets that come with Houdini. And you have like a bunch of different ones. I think in this case, I like the black body one, kind of gives it like that like lava type feel. One thing we maybe can do is right now, there's like no bump along these edges of like the glowing bits. And so we can actually plug in this noise using tool add. We can basically add like this noise on top of the other one. And you can see that's now included in like the bump as well, but it's kind of going the wrong direction. Like we want this to be inset. There's like lava underneath, and then the outer parts are, dried lava maybe or something. So we can use a tool invert to invert that. And now we're kind of getting that idea. So maybe we have lava that then dried on the outside, something like that. Or one other thing we could do is maybe add some darkness in the crevices using the dirt shader. We're just going to multiply this into the color using the tool multiply texture. Let's add some dirt in here. And then we can also set if we want to include like the ground, for example, which we don't. Yeah, that's kind of cool. And the flow noise, we could use this time to kind of offset everything. You could even animate this for like a cool animated like effect. Obviously you can do a lot more with this, but this is like one approach that's fully like procedural. When you're working on materials, sometimes you'll want to analyze and kind of like check out individual textures or things that you're working on and not always see like the whole material. In theory, you might want to just drag your texture directly into the material output, but that doesn't really work. And so we actually created a little kind of tool script that allows you to quickly preview any node in your node graph, at least any texture or material node. And you can either find that up here in the Octane Tools toolbar, you can find it in the right click menu. In Octane, I can select preview node, or what I like to do is actually, if you go to the Octane Tools toolbar and click edit tool, you can actually add a hotkey to it. And so what this allows you to do is if I just wanted to see this dirt real quick, I could just hit this button and I just see like isolated this texture, and it uses a little like preview shader here to do that. Or if I just wanted to see this noise, I could do that, or this gradient output looks like by itself. I think that can be a really helpful thing. You can also do this to kind of quickly apply a different material. So for example, if I wanted to quickly check out this metalness, I can like do that. And when you hit it again, it'll like switch back to the other one. Same with like one of the textures. If I hit this and hit it again, it goes back to the previous material. So that's just a quality of life type little tool we added recently. Let's talk about another situation that you're going to encounter all the time, and that is you have a texture set from like Grayscale Gorilla, for example, and you want to import it to Octane. So you could obviously do this manually, and the way we would approach this, we would drop down an image RGB node, we would navigate to our folder, which in this case I have like this Grayscale Gorilla maple wood planks texture here, and I would load my base color, and I would plug this into my base color. Actually, let's pick the lighter one. Let's do this pine, and then we could duplicate this, and maybe we could load next, we would load the normal for non-color images. So for example, for normal texture, metalness texture, roughness texture, you want to set this to non-color data, otherwise it's not going to look right. So we're going to use that, and we're going to plug it into our normal map, and then we will copy this again, and then we can pick our roughness and plug that into our roughness pin, and we already have in this case the 3 textures imported that they include here. However, now if we let's say we wanted to make these triplanar, we could like go in here and use our little triplanar function to set that up, and that is great. However, there's actually an easier way to import like texture sets. If you right click on here under Octane and select texture setup, we can just select our textures, hit accept, and this kind of gives us a quick checkup, because sometimes you have texture files maybe that are named incorrectly, or it's a very custom naming that's not recognized, so you basically can choose which pins to connect these to. So if we hit OK, now it loaded that for us and we're good to go. Let's say you're not just importing one material, but like a whole library of materials, and if you click up here under Octane batch material importer, it'll ask us, do we want to select the actual files or the folders that's in. So in this case, let's select the folder, and I have this Grayscale Gorilla folder here that has a bunch of materials in it. So if I hit accept, it will now try to analyze those materials, and this is what I found. In some cases you can do like a manual override and use some of these settings to like change how the materials are detected, but in this case we should be good to go. So hit OK, and then again we can kind of like make sure that all these settings are correct, and I think the only one that isn't correct is the sheen opacity, because there's no sheen opacity pin, so I think it just automatically selected opacity. So in this case we'll want to plug this into the sheen pin. But now if we hit OK, and if I just drag them onto here, we can see that we get some textures. The third and final material we're going to do is a glass material. So in our material, let's hop under the transmission layer, and let's just turn this transmission weight all the way up to 1. And we already see that we have some glass going on. And under the specular roughness here, we can kind of turn this down to make this basically like a perfectly clear glass, or turn this into like a really milky glass. So let's kind of choose something in the middle. And one thing we see here is that we have a lot of fireflies going on. There are a few ways to resolve this, especially with glass materials, but with other materials as well. Your render settings can make a big difference about how something is rendered and how efficiently it's done. And a big one with glass is going to be this GI clamp, and I've kind of gone over this I think a little bit in the render settings tutorial, but if we lower this down, we can see that this like really cleans up the glass quite a bit. We can also play with the caustic blur, and that can also kind of help improve things sometimes. And then another thing is adaptive sampling, and I usually turn this minimum adaptive sampling down as well. And what this just allows the render engine to do is to basically focus on the noisy areas of the image instead of sampling areas more that are already clean. And then maybe let's add some like color to this glass, so maybe like a red, and the transmission depth change, like is the color kind of like uniformly applied on the glass, or is it more applied as the light travels through the glass? So like thin areas of the glass would be less red and thick areas of the glass would be more red. Something that's also kind of fun sometimes is if you have like a pretty rough material, you can use a coating layer on top of that to add a secondary layer of reflection, kind of like if you had a clear coat on top of a car or something. So if I turn this off, we have like a pretty diffuse reflection going on here, and then if I enable this, we can see that there's like a secondary like sharp reflection happening on top of that. So that kind of can, depending on the material you're doing, can kind of be what you need, or just give it some more like visual interest by having multiple levels of reflection. And then one other thing that you can play with is specular IOR, which also affects your transmission. At 1, the glass basically becomes just invisible because it just travels, the light rays travel straight through, and then the higher you set this, the more of like a magnifying glass effect the material will have. And you can look these up online to find values for different materials. And one other kind of quick setup that I like to mess with when I work with glass specifically, the ray switch setup. So a ray switch tool allows you to basically modify a material based on the ray. And so in this case, let's drop down a material mixer. We're gonna plug our material into the first one, and we can kind of like mix these two materials using this mixer. And then on the second input, we're gonna use a material null, which is like a material that's ignored. So if I slide this all the way to 0, you can see that this material basically just turned invisible. But what this kind of setup lets us do, that if we plug in the ray switch into the amount, now we can basically turn the material invisible to certain rays. So for example, if you want a glass that's really light, you could turn off the shadow ray. And of course, this is not going to be like physically accurate, but in some cases you kind of want like a glass that has like a very light, bright feeling to it, and disabling it to shadow rays or lessening in that can kind of help do that. All right, thank you guys for watching. This is going to be it for this video. Like I said before, we're going to go into more detail on certain subjects in future videos, and if there's anything specifically you would like to know, please let us know either here in the comments or on Discord. But yeah, appreciate you watching. Hope you have a wonderful day. Happy rendering.